All right, guys, welcome back to Burt's Basics. My name is Peter Burt. I teach at Bucks Elder High School, and today we are going to, let me move my face off these words, we are going to be focused on special senses, especially the ear today. So here is a list of everything you are supposed to know for the ear, for Burt's Basics, from the State Core in Medical Anatomy and Physiology. Now, I'm going to try as hard as I can to cover all these guys. At the end of this, I have the coolest YouTube video known to man that will really help you guys understand this. But I mean, I know there's a lot of words on here and it looks kind of scary. So let's try to make this as simple as we possibly can. So here you guys go. I'm just going to go ahead and start drawing and you guys start taking notes like you know how. Okay, so the ear. The ear is one of the coolest things to teach. It's also one of the hardest things to understand. So ear is divided into sections. We have an outer ear, we'll do in blue. We'll have a middle ear, which we'll do in red. Okay, that just kind of helps me understand where I'm going. And an inner ear, we're going to do in green. Right away, you can see there's going to be lots of questions on this, like where does hearing take place? Outer, middle, inner. Where are the ossicles? Outer, middle, inner. So let's just do each one very quickly. Outer ear. Outer ear has your ear. Woo, okay. He goes by lots of names. He goes by auricle for the folds in the ear. He goes by pinna. Okay, he kind of has a lot of names. But the whole point you need to know about your outer ear is when sound waves hit it, it funnels it down your auditory canal. So now I gotta have a place where this guy ends. So your outer ear will come on in here and we have cerumen, okay? Cerumen, okay? Cerumen is earwax, okay? That helps keep my ear clean, keeps bugs out, helps keep water off my ear, stuff like that. We can talk about swimmer's ears. I got some cool pictures for you here in just a second. But my outer ear ends at a drum of some sort. And that drum is called your tympanic membrane. Okay, tympanic membrane is going to be a lot of questions. That's a Y, by the way. Your tympanic is because it's going to be your eardrum. So what happens is sound waves will come, they'll travel down, they'll hit your eardrum, and they will cause it to vibrate. And that is your outer ear. So I'm not going to ask a ton of questions on the outer ear besides some of the basics as far as funneling sound waves, tympanic membrane, cerumen might be in there. Okay, there's a couple questions, but not too many. Most of my questions are going to be in the middle ear. So let's go ahead and talk about middle ear. And I got to switch my pen now to red. In your middle ear, okay, I'm going to draw it as a box, okay? In your middle ear, you have what we call the ossicles. The ossicles are three small bones, and we have one that connects to your tympanic membrane, and then it shakes the next bone that it connects to, and it shakes the next bone that it connects to, and these three bones are in a series, and they're called ossicles, which literally means small bones, ossicles, okay? Their names are the malleus, the incus, and the stapes. Okay, I'll show you pictures of these guys in a second. Right now, we're just doing general of the ear. What happens is the vibrations then will transfer to one to the other. Now, this should be a cavity mostly full of air. Every once in a while, it does fill with fluid. So now if this is a problem and it starts to fill with fluid, you can see that this could be a problem because now it can put pressure on your eardrum. And we call that otitis media. Okay, that's going to be one of our definitions we have to talk about. Otitis media, middle ear infection. Okay, two words, otitis media. So lucky for us, we have a drainage pipe. Whoop, whoop. And that drainage pipe, it was called the eustachian tube. We don't really call it the eustachian tube anymore. We call it the auditory tube now. That's probably more appropriate. You guys know this because anytime you go through the canyon, this is why you yawn. You yawn to open this tube to equalize the pressure in your middle ear, and you're like, hey, my ears just popped and I feel fantastic. Okay, that's what that guy's all about. Unfortunately, if air can go out, then we can also have some bad guys coming up in here, and that's why we have middle ear infections. I'll show you a picture a little later on why kids tend to get otitis media a lot more than adults, okay? But that's kind of where this guy comes in. Remember, this is basic, okay? We're doing more complicated in a little bit. Now let's get to the inner ear. Now, the inner ear is where craziness happens, and I like to divide it into two parts because there's one side is for balance, and one side is for hearing. Now, in this class, we tend to only focus on the hearing side, but you should probably know a little bit about both. Okay, so let's start with the hearing side first. Let's do hearing. So as soon as it gets in here, it will go to this big old snail-like shell. Woo! Okay, and that big old snail-like shell we call the cochlea, which actually means snail in med terms. So that is your cochlea. Now the coolest thing about the cochlea is it's like a two-way road. Doot, 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 doot. So we have one road going up and one road going down. And what ends up happening is the stapes pushes on this road, and this is full of fluid. So if we talk about how this hearing works, like I said, the YouTube video is going to be the most helpful. It's kind of hard to do this on a video lesson. But as we talk about this stapes then pushes on the fluid. Now fluid is going to travel, okay, because fluid can't compress. So if you push on the fluid here, now you have the ripple effects go all the way up to the top of the shell. But good thing I have a road coming back down, because then it can come all the way back down, and I have a little release valve here, which we'll talk about the windows in just a second. And that's what hearing does. So sound waves come in your outer ear. They transfer to the middle ear. The middle ear, the bones help vibrate the sounds and put it towards the inner ear. In the inner ear, you have fluid. This fluid travels up and down. This is called your scale of tympani and scale of vestibuli, which we don't need to know for this class, but we need to know the cochlea is where this is going to travel. Now, inside here, I'm going to switch to black. There's a very special organ. Okay, this organ is called the spiral organ, or the organ of Corti. Okay, I learned it organ of Corti, so that's probably what I'm going to use more than spiral organ. In the organ of Corti, they have these guys. Now I'm praying and hoping that as soon as I draw them, you will feel comfortable. Do you guys know who that is? That right there is an axon. Okay, that is a neuron, something that will gather information and understand it. So what ends up happening is you have a fluid-filled chamber. Okay, so here's fluid-filled chamber. That's going upstream. And then you have a fluid-filled chamber. That's going downstream. And then in between these, you have this cool spiral organ, which I always tend to draw as a triangle. And then on these guys, you have all these modified dendrites. You guys know what dendrites are. Dendrites are the ones who are going to sense the information. So what happens is this fluid starts to transfer, it has kinetic motion. That kinetic motion then puts pressure on a plate. This guy's called the tectoral plate. This is more information than you need for this class, but if you take Weber next year, you're going to need to know every single part of these. And what happens is it pushes down. So if I can kind of go to my face for a little bit, see if this makes a little more sense. Okay, so what ends up happening is these dendrites are just sitting up. And think of my phone as the plate. It's just sitting there. It's not touching. But every time the fluid goes by, it can hit my fingers. And every time it hits my fingers, those dendrites send a signal. And that's how hearing takes place. We transfer from a fluid motion to a nerve impulse in the organ of Corti, or what we call the spiral organ. Okay, so as this fluid goes by, it pushes these guys down. So can I zoom in on these guys really quick? Let me zoom in here really quick. There's my tectoral plate. Here's your dendrites. They call these dendrites, specialized dendrites, hair cells. They're not hair, but they actually look a lot like hair. I'll show you real pictures of them in a second. And as soon as these guys make contact, so as soon as this guy comes down and this tectoral plate pushes on these dendrites, that's when sodium gates will open. Please tell me you guys are okay with this. Sodium gates open, sodium comes rushing in, I create an action potential, and then it leaves on an axon called your cochlear nerve. So now the question is, what happens if you're at a concert and this tectoral plate is smashing those hair cells again and again and again and again? Well, then I have bad news for you. Dun, 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 dun. These hair cells can break. See how he's laying down and he's got excess for eyes? And that's where we get hearing loss. Hearing loss is when we break those hair cells. And I have bad news for you. They don't grow back. And the way you can tell if you have hearing loss is through tinnitus. Okay, some teachers pronounce this tinnitus. I learned it tinnitus, so you can do it tomato, tomato. Tinnitus is the definition of when you have ringing in your ears. If you go to a jazz game, you go to a concert, something, that means you damaged your hair cells. And that means you have some lesson part of hearing loss. Now, if you guys remember, can I go back? You guys have this cool cochlea. This is a gigantic keyboard. Now what that means is if I could take this cochlea and kind of draw it out so it's on its own. So instead of drawing it like this in this big old cochlea shell, let's draw it like this. Lay it all the way out flat. It's like a gigantic keyboard. And every part of the keyboard hits a different decibel range, different pitch, if you will. So guess what happens? If you're at a concert and it's hitting here all the time for 2 hours, you're going to damage your hair cells here. But if you're listening to music, then guess what? You get different sound waves at different frequencies, and they can hit all this at different times. So your cochlea is just one of the coolest things in the world with the organ of Corti in there. So now let's go ahead and go through some pictures really quick. Okay, there's your pinna, or your outer part of your ear. Okay, there's your ear canal. This is earwax built up inside of an ear. I like the picture on the right. That's a Q-tip stuck in someone's ear canal. Okay, there's your eardrum. So cool, it's transparent. If you can see, there's bones on the other side. And remember, the malleus is the bone that will actually stick to your eardrum, which I think is the next picture. Okay. Okay, those, if you guys wanted to look at those, you can pause the video. These are if you put pipes, pressure equalization tubes in someone's eardrums. Say their middle ear keeps filling up with fluid, like you see in this bubbles. This would be an example of otitis media. It's not supposed to have fluid in there. That's why kids struggle so much with that. Okay, if you look, here are your bones. Okay, they're your malleus, your incus, and your stapes. Now you guys can call them the hammer, anvil, and stirrup. I don't mind that, but I want to give them by their real names. These are them. So what happens is sound waves hit your tympanic, they move your malleus, which then in turn moves your incus, and then it moves your stapes. And the stapes then pushes on the window. Okay, let's go to my next picture. Okay, so there's your two windows right there. So if you notice, I have two windows. I have an oval window, and I have a round window. The stapes pushes on this one. So then the fluid can go up the scale. And then when it comes back down the scale, you need an escape window, which is the round window. It's like a speaker. Okay, think of it like a waterbed. If I push in here and I push down on the water, well, the water's got to come back somewhere, and it pushes back. So these are the fluid stays in there. It's just the oval window is where the pressure starts, and the round window is where it comes out. If you guys watch a YouTube video, I promise you this will make way more sense. It's so cool. Okay, now let's look at your hair cells. Okay, so far this is the only one we talked about. Okay, we're going to talk about these guys later. These guys are called semicircular canals, and they kind of get their own video in the future. These guys is all about the balance side. So do you remember how I said the inner ear has two parts? We have the balance side and we have the hearing side. So right now we're only focusing on the hearing side, which is just my cochlea with my oval and round windows. Okay. These are what hair cells look like. They're really, really, really cool. They're just modified dendrites or parts of a nerve. And this is you having tinnitus after a concert, just with them beat up and destroyed. Okay. Now, I know that was kind of a quick video, okay, but I think we covered most of the words, but you gotta watch this. This is a non-negotiable. This is without doubt the coolest video in the world. I'm gonna show it in class because it just is. So let's just double check to make sure we covered most of the words we needed. Okay, auricle is the outer ear. Okay, canal, tympanic membrane's your eardrum. You got your malleus, incus, and stapes. You have your eustachian tube, which is your auditory tube to drain your middle ear. Okay, the labyrinths are just what they're in. Okay, the semicircular canals, that's a big one. Semicircular canals, that's where you can write balance. That gets its own video in the future. Okay, cochlea, we want to say that's where hearing takes place, but I would rather you to know that as the organ of Corti. Organ of Corti is where your hair cells are found. Organ of Corti is where your hair cells are found. Okay, tinnitus, ringing in the ears. Middle ear infection, otitis media. Okay, vertigo, that's a semicircular canal problem, because remember, semicircular canals are balance, so that goes with vertigo. And deafness, there are two types of deafness. There's getting the sound waves to the hair cells, which is conductive hearing loss, or if the hair cells or nerves struggle themselves, then that's sensory neural hearing loss. So it depends on what kind of deafness that we actually have. Now, I always end with a quiz. I am not ending with a quiz on this one because I'm telling you, your quiz is to watch this video. It's like 3 or 4 minutes, and I promise you, it will explain the ears 1,000 times better. Thanks, guys, for watching, and I'll see you on the flip side.